Okay, so here it has been told that if the matrix A is 0 minus tan alpha by 2 and tan alpha by 2, 0, and I is the identity matrix of the order 2, and I is actually I2, means it is the identity matrix of order 2, then we have to show that I plus A, that is equals to I minus A into cos alpha, I plus A equals to I minus A into, sorry, I minus A into cos alpha minus sin alpha, and cos alpha. So therefore, the left hand side, which is equals to I plus A, that will be equal to I, which is 1001, plus alpha A, which is 0 minus tan alpha by 2 and tan alpha by 2, 0. So if we add them, then we will get 1 minus tan alpha by 2, tan alpha by 2, and 1. So now, therefore, the right hand side, that will be equal to I minus A into cos alpha minus sin alpha, cos alpha. So now, therefore, I minus A, that will be equal to 1 0, I is 1001, and minus of this A, which is 0 minus tan alpha by 2, tan alpha by 2, 0. And with that we have to take the product with cos alpha minus sin alpha, cos alpha minus sin alpha, and sin alpha cos alpha. So therefore I minus A, that will be equal to 1 minus 0, that is 1, 0 minus of this, that is tan alpha by 2, 0 minus this, that is minus tan alpha by 2, and 1 minus 0, that is 1, into this will be cos alpha minus sin alpha, and cos alpha. So if you take the product, therefore the right hand side, that will be equal to 1, then what? Then tan alpha by 2, then minus tan alpha by 2, 1, into that will be cos alpha minus sin alpha, and cos alpha. So this will be, so now we have to do the product of first row and the first column here. So this will be 1 into cos alpha, that is cos alpha, and plus this is sin alpha into tan alpha by 2. And here this will be first row into second column. So this will be minus sin alpha, then plus cos alpha into tan alpha by 2. Then here this will be second row into first column. So this will be minus cos alpha into tan alpha by 2, then plus sin alpha. Then here second row into second column here. So this will be sin alpha into tan alpha by 2 plus cos alpha. So now this can be written as, now this is sin alpha by 2 into cos alpha by 2, I can write. So if you take the LCM, this will be cos alpha into cos alpha by 2 plus sin alpha into sin alpha by 2 divided by cos alpha by 2. Then so now in here also we can take the LCM. This will be sin alpha, then this will be cos alpha into sin alpha by 2 minus sin alpha into cos alpha by 2 by cos alpha by 2. Then here also, if you take the LCM, this will be sine alpha by cos alpha by 2. So this will be sine alpha into cos alpha by 2 minus cos alpha into sine alpha by 2 divided by cos alpha by 2. And this will be, again, we can take the LCM. This will be sine alpha by 2 into cos alpha by 2. So this will be cos alpha into cos alpha by 2 plus sine alpha into sine alpha by 2 whole divided by cos alpha by 2. Now this will be equal to, now cos A cos B plus sin A sin B. This is cos A minus B. So this will be cos alpha by 2. And here also this is cos alpha by 2. And this is sin A. So this is sin A cos B minus cos A sin B. So this is sin A minus B. So this is sin alpha by 2 minus alpha by cos alpha by 2. And this will be, so this is also sin A cos B minus cos A sin B. So this is sin alpha minus alpha by 2 by cos alpha by 2. And this is cos A cos B plus sin A sin B. So it is cos A minus B. So this is also cos of alpha minus alpha by 2. This is cos alpha by 2 by cos alpha by 2. So now this can be written as, this is 1. This is 1. Since these two will cancel out. And this will be sine of minus alpha by 2. So sine of, we know that sine of minus theta is minus sine theta. We know this. So therefore, this will be minus sine alpha by 2 by cos alpha by 2. And then this will be sine alpha by 2 by cos alpha by 2 by cos alpha by 2. And this is 1. So therefore, the final answer is coming 1 minus tan alpha, sorry, 1, then minus tan alpha by 2, and this will be tan alpha by 2 and 1. So this right hand side, as you can see, it is coming similar, it is coming exactly same as the left hand side only. So hence proved. So hope you have understood the concept. So thank you.